Hello. In today's lesson, we will discuss the concept of electric field. What does a field means? Now, look at this board one more time. I have an electrically charged plastic sheet. If I bring it near the electric ball, you can see what does it do? Well, this carries a negative charge. This also carries a negative charge. You notice that the ball is being pushed away. Now what that means is this charged object is now under the influence of this charged object. You see that? Well, I'm going to, all right. Now they are charged equally. There you are. Now, why is this force happening? The force happens because this ball is placed in the electric field of this charge. Now, that is the reason why the forces exist. Now, one more time. A charge exerts a force on another charge. Yes. You can see this charge exerts a force on the other charge because this charge is now placed in the electric field of this charge. So how will you define an electric field? Well, I can say, you see, I can place it anywhere here. That charge is being pushed away. So I'm going to define an electric field using this concept. How am I going to define it? Electric field of this charged object is a three-dimensional space around that charge where it will exert force on other charges. Isn't that a good definition of electric field? So what is the definition of electric field? Electric field is a three-dimensional space around a charge where it will exert force on other charges. Now the concept of a field is not only used to explain forces between electric charges. It can be used to explain forces between magnets, the forces between objects like gravitational force. All these forces can be explained by using the concept of a field. Force between two objects, whether it is electrical, gravitational, or magnetic, can be explained using the concept of a field. Now, a three-dimensional space where a force can be detected is a force field. Is that right? A force field is a region, a three-dimensional region where a force can be detected. For example, the space around the Earth where the gravitational pull of the Earth can be detected is the Earth's gravitational field. Now, if I drop this ball, why does the ball fall? It falls towards the Earth because it is placed in the Earth's gravitational field. Anything that is thrown up comes back because the objects are in the gravitational field of the Earth. The region around the Earth where it will exert force on other objects is called the gravitational field of the Earth. Here I have the Earth, and anything that is placed around it will be pulled towards the Earth because of the gravitational field. An object of mass m has a weight mg because of the gravitational pull. See, the moment you take the object away from the gravitational field, that object will lose all its weight. There will be no more force on it. In the same way, there is a space around an electric charge. Now, if this is the electric charge we are talking about, there is a space around that electric charge where it will exert force on other charges. And that space or that region is called the electric field of that particular charge. All right. This space is called the electric field of that charge. A positive charge attracts a negative charge because the negative charge is in the field of the positive charge. You see, this is a positive charge. It attracts a negative charge because this negative charge is placed in the field due to that positive charge. Alright, let's see, we can look at the visualization of the electric field. Now, if the yellow ball at the center is a positively charged object and a large number of tiny test negative charges are placed in the region surrounding that, look at the way all these charges are falling towards it. Now, doesn't it behave almost exactly like the gravitational field of the Earth? All these negative charges are placed in the field due to this positive charge. So here we have a good visualization of electric field. Electric field of this charge, the yellow object there, is a three-dimensional space around it where it will exert force on other charges. That means if all these are negative charges, those negative charges will be pulled towards it. What happens if you place similar positive test charges in this region? They will be all repelled away. So here is a good illustration of electric field. We will now discuss the concept of intensity of an electric field. What does that mean? Intensity. How intense is the electric field? In other words, intensity of an electric field gives us an impression on how strong the electric field. How do we calculate the amount of force that a particular charge experiences when placed in an electric field? Now, electric field is a vector quantity. Why is it a vector quantity? Because it is measured in terms of the force experienced by a test charge. It has a magnitude and a direction. The magnitude of the electric field is called the intensity of the electric field. In other words, the intensity of the field is the strength of the field. How strong is the field? Now we will represent the electric field by the letter E. And when you use a vector, we will represent this by an arrow at the top. So E with an arrow will be the electric field vector. The intensity of electric field E. So at the moment we are only considering the intensity, the magnitude of the electric field. Now how is it defined? It's defined as the force experienced per unit test charge placed at that point. So if I want to determine the intensity of the electric field due to this charge, now here is a charge here. If I want to find the intensity of the electric field at a point where my pointer is, all I need to do is place a test charge there and measure the force it experiences. And the test charge, what is our test charge? You see, because we have two types of charges, a positive or negative, we must choose between them. And all over the physics community, it is understood and accepted that we will use a positive charge as a test charge. So if I place a unit positive charge here, the amount of force that unit positive charge will experience will give me a measure of the field intensity at that point. So one more time, electric field intensity is defined as the force experienced per unit test charge placed at that point. Electric field at a point is a vector quantity. It has both magnitude and direction. The magnitude of the field is what we call the intensity. And it becomes the field vector when you combine the intensity with the direction of the field. Now, let's consider a charge Q0, which is a test charge, placed at a point P, distance r from a charge Q. Now, this is the charge Q. Alright, our point P is here, and point P is at a distance r. This distance is r, and we place a test charge Q0 there. And of course, remember, a test charge is a positive charge. That means this test charge will experience a force due to this charge Q. What is that force? Can you tell me? If you know Coulomb's law, you can tell me that force. Using Coulomb's law, the force on Q0 due to this big charge Q is F equal to K Q Q0 over R squared. Now, this is a measure of the force on this charge Q0. And therefore, if I place a unit charge there, what will be the force per unit charge? The force on a charge Q0 is this. What will therefore be force per unit charge? The force experienced by a unit charge placed at P will be this force divided by Q0, because this force is experienced by a charge Q0. Therefore, what is the force per unit charge? It will be F over Q0. And when you divide this F by Q0, the Q0 will cancel, giving us KQ over R squared. This is a very important quantity. What does that represent? It represents the intensity of the electric field at a point distance r from a charge Q. Intensity of electric field at a point distance r from a charge Q is KQ over R squared. So E, what does E stand for? Intensity of electric field at a point distance r from a charge Q is E equal to KQ over R squared. Don't forget that. We need that right through the course. Alright, so what's the unit for measuring E? Remember, the E is measured as the force per unit charge. Force is measured in Newton, charge is measured in Coulomb. Therefore, electric field intensity, which is the force per unit charge, is measured in Newton per Coulomb, force per unit charge.